Our task is to print all permutations of the elements of a given string. Let's build an intuition on how we can build our algorithm. Let's consider a string of length n. Then it would have n factorial different permutations. If the first element is fixed, the number goes down to n minus 1 factorial. The first element can have n different values, that is, it can be swapped with itself or n minus 1 different elements. Let's consider a sample string. Say the sample string is man, M-A-N. Here, m can be swapped with itself, it can be swapped with a, or it can be swapped with n, that is the first, second or third element. So say it swapped with itself, that would yield the string man. It swapped with the second element, that would yield amn, and it swapped with the third element. So we built 3 possible cases for the first index. Now that the first index is fixed, say m was swapped with itself, the remainder of the string here would be an. In the remainder of the string, we apply the same algorithm. A can be swapped with itself to yield an, a can be swapped with n to yield na. So for each of the 3 cases, we get 2 possible subcases. Hence, we get a total of 6 cases which represent different permutations. Now let's consider a recursive approach to the algorithm. Let's consider the algorithm using a recursion tree. The way we process our input is by considering possible values that might occur at each index. We do this by swapping the value with other possible values and processing the rest of the string recursively. Initially, say we pass the string man. It's the same string that we considered in the previous case. Here, m can be swapped with itself to yield man. It can be swapped with the second element, or it can be swapped with the third element. So we get 3 possible cases. It's important to remember that initially the length of the string was 3. After the first pass, the length has reduced to 2. Now we can process the algorithm recursively for a string of length 2. Again, we fix the second element, and by 2 possible swaps, we can get 2 possible subcases. That is, a can be swapped with itself to yield man. A can be swapped with n to yield mna. It's important to remember that after each pass, the length of the remaining substring goes down by 1. So over here, the length of the remaining substring that is to be processed goes down to 1. When the length of the remaining substring goes down to 1, we abort the algorithm and print the permutation. So we get a total of 6 permutations for the string. Let's consider a formal approach to our algorithm. The recursive implementation of the approach that we are considering is implemented through the function permutation. Str is the name of the string that we are passing, I is the starting index that we are considering, and n is the end of the string. I is equal to n represents the case when the whole string has been considered and only one element is left. In that case, we simply output that particular permutation. Else, we swap the ith element, that is the starting element that is continuously incremented, with the rest of the elements to yield different permutations. After swapping, we pass the remaining array that we have changed through the function permutation recursively. It's important to remember that the value of the starting index is incremented by 1. Let's consider our example once again to illustrate our approach. Initially, the value of I was 0. After the first pass, the first element was fixed. Now the value of I was incremented to 1 and the remainder of the string was considered, which consisted of 2 elements. Here the value of I was 1. Similarly, after the second element was fixed, the third element was considered. Here the value of I became 2. When the value of I became 2, we simply outputted the string. Let's consider how our algorithm would appear on the console of a compiler. We'd get 6 different values which represent different permutations of the string man.